Hello everyone, I am Professor Amit Thakur and today's topic is linked list implementation using C. In this topic, we are going to cover several things like creation of linked list node, search for specific elements in the linked list, insert a node at a given position in the linked list, and the last, delete a node at a given position in the linked list. So, these are the operations we are going to perform with the linked list. The learning objective of this session is, after this session you will be able to discuss the creation of linked list node, explain the concepts of searching for a specific element in the linked list, explain the concept of inserting and deleting node in the linked list. So, this is the objectives which we are going to cover with this session. The concept of linked list has been around for a long time and it has evolved over the course of the computer science history. This development of linked list and similar data structure can be attributed to the collective efforts of many researchers and computer scientists. One notable early contributor to the concepts of linked list is Alan Newell, who along with J.C. Shaw developed the information processing language, that is IPL, in the late 1950s. IPL included ideas that influenced the development of linked data structures. Another significant contributor is Christopher Strachey, who worked on the CPL, that is Combined Programming Language project in the early 1960s. CPL introduced the idea of linked list and dynamic memory allocation. The development and the usage of linked list continued to evolve with the advancement of computer science and programming languages. Many subsequent researchers and educators contributed to the refinement and implementation of linked list, both as a standalone data structure and the building blocks for the more complex data structure. It is important to note that the concept of linked list structures is a fundamental idea in a computer science and has been independently developed and used in various contexts by multiple individuals and research groups over the time, such as it is not an attributed to a single person or specific developer, but rather represents a collective effort within the field of this computer science. So, we will talk about what is linked list and what are the definition of linked list first. A linked list is a linear data structure used to store and organize a collection of elements, that is also we can know as a nodes, in a sequential manner. Each node in a linked list contains two components. The first component is data and the second component is reference, or sometimes we can say it is a pointer to the next node in the sequence. The data component holds the actual value or the information of the element, while the next component, that is reference or pointer, points to the next node in the linked list. Here we can see in the diagram, I have taken 4 nodes in the linked list. The first section of this node is known as data and the second is known as pointer, which is pointing to the next node. Here I have taken node data like A, B, C and D. Each node constitutes the address of the next node. Here we can see 2 pointers also. This first is head. The head is a pointer responsible to hold the address of the first node, and the null pointer, this is the last node address. It means the next node is not available, means this is the last node of the linked list. The linkage between nodes is what gives the linked list its name. Each node points to the next node, forming a chain like structure. The last node in the list usually points to the null value or a sequential sentinel nodes to indicate the end of the list. Now, we will talk some applications of linked list, where we can use this linked list and what are the applications where we can apply. Like linked list have varieties of applications in computer science and software development. They are particularly useful in scenario that requires dynamic data structures with efficient insertion and deletion operations. So, here are some common applications of linked list where we can use this linked list. The first is dynamic data structure, where the size of the structure is not fixed. So, we can use in this type of data structure, I can use this linked list. Second application is implementation of other data structure. Suppose we want to implement other data structure with the linked list. So, linked list very useful. Third is memory management. So linked list also are very efficient for the memory management kind of data structure. The next is undo functionality. Sometimes we feel the functionality should be changed or unchanged. So in this case we can use this linked list. Also we can apply this music and playlist management. So this is better way by which we can manage this kind of application with the linked list. These are just a few examples of many applications of linked list. The flexibility and the efficiency of linked list makes them a valuable tool in various areas of computer science and software development. Also, when we talk about some additional applications, we can know that text editors we can use with this linked list. The graphics kind of application we can use this linked list. Symbol table and compiler design, this is a famous and this most researcher area and researched area. We can use this linked list to develop a symbol table and compiler with the help of this linked list. Operating system task management, web browser, garbage collection, simulation and modeling, these are some few applications that is possible with the linked list. Now we will come with different variations with the most common types being with the available with the linked list. We have first is singly linked list. Each node has data value and single pointer or reference that points to the next node in the sequence. So this is a singly linked list. Next linked list is a doubly linked list. Each node has a data value and two pointers. The first pointer points to the next node and another pointer points to the previous node. So this allows the traversal in both directions. It is a bi-directional traversal. Next is circular linked list. Similarly to a singly or doubly linked list, but the last node pointer or reference points to the back to the first node. That creates the circular structure, means the last node having the address of the first node, and it is similar like singly and doubly linked list. This is the main difference between the singly and doubly linked list with the circular linked list. Linked list have several the linked list offers some several advantages and also some disadvantages with the data structure. So first we will talk about the advantages of linked list. The first advantage of linked list is dynamic size. The linked list can be dynamically grow or shrink without requiring the entire structure to be moved or reallocated. This is the most and powerful this advantage of this linked list. Second advantage of linked list is efficient in insertion and deletion. It is very efficient data structure while we talk about the insertion and deletion of the elements. Adding or removing element in the middle of the linked list can be efficient as it only involves updating the pointers without the need of the shifting elements. In this case the array is most complex data structure while we talk about insertion and deletion of the element. In this case in linked list it is very efficient data structure in case of insertion and deletion. The next advantage is memory allocation flexibility. The nodes can be allocated and deallocated independently, making memory management more flexible. Here each node are independent with the different nodes. So without making more trouble, we can simply memory can be allocated for the different nodes. Now we will talk about some disadvantages of the linked list. The first disadvantage of linked list is sequential access. Unlike arrays, accessing a specific elements in a linked list, it requires traversing from the beginning of the list, which can be less efficient for a certain operation. The second disadvantage of the linked list is extra memory usage. Each node in a linked list requires additional memory for storing pointers, or sometimes we can say the reference, which can lead to the higher memory consumption compared to the array. Here one more node that is reference is other things other segment of the linked list. It takes more memory than the array. In summary, a linked list is a data structure that consists of nodes where each node holds data and reference pointer to the next, and linked lists are particularly useful when dynamic resizing and efficient insertion and deletion are prioritized, but they might not be as efficient for random access or as array or other data structure can be applied. List might not be the best choice in the following situation. Sometimes we feel that we know how we can use the data structure when we have to use data structure. So these are some cases where linked list might not be the best choice for following situation. The first is random access. If you need frequent random access to the element, arrays are usually more efficient due to their contiguous memory allocation. The second case where this linked list might not be the best case is memory overhead. Linked lists have their higher memory overhead compared to the array because of the additional memory needed for the pointer or reference. Third situation is cache performance. Array benefits from the better cache performance for sequential access due to their contiguous memory layout. The next situation is complexity. Linked list can add complexity to the code compared to the simple data structure like array. The code is much sometimes it is much complex code as compared to the array. In summary, linked lists are valuable when dynamic size, efficient insertion or deletion, and flexibility in memory allocations are important. However, the choice of data structure should be always depend upon the specific requirements and the constraints of your problem. So, now we'll talk about the creation of the linked list node, how we can create node to the linked list. So, there are certain steps are involved. First of all, the first step is allocate the memory. Allocate memory for a new data or new node to store the data and the reference pointer to the next node. This memory allocation is typically done dynamically using a programming languages memory management functions. This is the first step, and the second step, set data. Assign the data to the value you want to store to the data field of newly allocated memory. The next step is set next pointer or reference. Set the next pointer or reference of the new node to null or none initially. This step establishes the link to the next node in the linked list. The fourth step, this fourth step is optional, but we can consider here link nodes. Depending on where you want to place the new node in the linked list, you may need to update the next pointer or reference of the previous node to pointing to the new node. This step is crucial to maintain the logical sequence of the linked list. Last but not the least, the fifth step is return node. If needed, return the newly created node from the function or method that performs node creation. You need to create their own function that function creates the node and that function returns the node. So, this is how we can return the node. These steps allow you to use created node in other parts of your code. So, this is implementation or code to create a singly linked list. This is a sample code where you can simply create a node for your linked list. Here I am using 3 header files with my source code, that is stdio.h, kuno.h, and the last is alloc.h. Alloc.h is responsible because I am using certain functions which are defined in this alloc.h header file. First of all, I am declaring a structure. This structure also known as a self-referential structure, because this pointer reference, it makes this structure as a self-referential. In this structure, I am taking two these members. The first member is information or data members. Second is structure node, that is pointing to the same type of structure, that is struct node, and pointer I am taking here as a next. So, this is structure I am defining here, and the two variables I am going to take here, like struct node head and then starting as and this initializing as a null, and second variable is pointer tail, and these two pointers type of struct node. Here the next point is I am just declaring or implementing a function, defining a function like create node, and this create node function returns a pointer or reference of structure node. In this inside this implementation, I am simply declaring a variable temp. The temp is a type of structure node pointer. The first thing is I am using the malloc. Malloc function is responsible to allocate the memory at dynamic time. So, with this malloc I am allocating the memory and providing to the temp. After this I am writing a message like enter the data, and I'm with the help of scanf function, because here I am considering as a decimal data. So, I am writing %d and address of temp of info. This is how we can take the data and store the temporary data into the proper information variable, and at the last we can create temporary to the next of null. So, I am providing this null value to the temp of next, and at the last point I am returning this temp. This temp is nothing but it is a creating a node and returning it from the function. So there is a one display method. Display method simply I am writing with opening and closing curly braces. Inside this I am taking one parameter, one variable like struct node pointer t. I am taking a one loop starting from t equals to head, t does not equals to null, and t equals to t of next. So this is how this will traverse to the linked list, and this will simply print with this t arrow of info of decimal value. This is how we can print the linked list. After this I am taking this main function, and this main function I am taking one variable answer equals to y of character type, and again I am taking new node pointer with the type of struct node. Now I am taking one condition, I am taking one loop. In this loop, while loop, I am taking one condition like answer equals to y, small case or uppercase, both will be admissible. The next thing inside this this loop, I am creating create node. I am just calling this function, and this create node will be pointed by new node. So the new node will be assigned to the this new node variable. And now I am checking if head equals to null, means this if head having this null value. Now this might be updated. So I am head equals to new node, and after this tail equals to new node. This is how the first node will be created. If nothing goes well, it will go to the else part, and else part tail of next equals to new node, means the new node will be brought to the tail of next if already their node is available, and tail equals to new node. This is how the node will be created. After this loop, I am printing a message want to continue. If user want to continue, it will press yes. If you press yes, it will again go to the loop, and this is how we can display this linked list node. Now we will talk about the search for a specific element in the linked list. Searching for a specific element in linked list involves traversing through the list and comparing data values in each node until the desired element is found or the end of the list is reached. Here the some steps are possible to search for a specific elements in singly linked list. The first step is start, means beginning at the head of the linked list. Second step is initialize current node. Set a current node pointer to the head of the linked list. The third point, traverse the list. In this third point, again we can consider three more points. The first point is compare the data value of the current node with the target element you are searching for. This is the first step. Inside this step, again there is another step is possible. If data matches, the search is successful, and you can return or process the current node. This is second step. Third step is if the data does not match, move to the next current node, pointer to the next node using the next pointer variable. This fourth step is repeat step 3. Inside this fourth step, again we have two more steps. If current node pointer is not null or none, go back to the step 3 or continue the comparison and traversal. Next step is if current node pointer is null or none, the search is unsuccessful as the target element is not present in the linked list. The last step is end. The search ends when the target element is found, that is step 3b, or when the end of list search without finding the element in the target element in the linked list, that is step 4b. The search algorithm iterates through the list, comparing data values until the target element is found or the end of the list is reached. The actual implementation details may vary based upon the programming languages and the specific linked list structure by what we are using. I am writing here, I am writing a function for search for a specific element in the linked list. Here the search node is a function name which takes two parameters. First parameter is head. This head is of type of struct node of pointer, and second is a data. Inside this again I am taking a variable name temp, and that temp will be assigned a value of head. In this again I am writing a loop, while loop. In this while loop I am just simply writing a condition where temp does not equals to null. If temp does not equals to null, it will go inside this loop, and again in this loop I am writing an if statement, and if statement says temp of data equals to data. If condition is matched, then it will return a temporary variable, otherwise it will return temp equals to temp next, and last if condition is false, it will return simply null. Now we will see insert a node at a given position in the linked list. This is how we can insert a particular node into the given position into the linked list. Inserting a node at a given position in a linked list involves updating the pointers or reference of the node to include the new node at the specified position. Here are some steps that are involved to insert a node in a given position in a single linked list. So, need to follow some certain position to certain steps, a certain position starting with. The first is start, begin at the head of the linked list. This is the first step. Second step is initialize current node, set a current node pointer to the head of the linked list. The third step is traverse to position, traverse the linked list until you reach the node just before the desired insertion position. This means moving through the list position -1 times. Fourth step is create the new node, create the new node with the data you want to insert. The fifth step is link the new node, set the next pointer of the new node to the point to the node that contains after the current node. Sixth step is update previous node's pointer, set the next pointer of the previous node, that is at position -1, 2 points to the new node. This is next step. And the last step is end insertion is complete. This is how we can insert a node to the linked list. The function handles inserting at the beginning as a special case, otherwise traverse the list to the node just before the insertion point, updating pointers to include the new node. The actual implementation details may vary based upon the programming language and the specific linked list structure you are using. This is the function I am writing over here. The function name is insert at position. So, you need a position from the user. The function says a function takes 3 parameters. The first parameter is head, second parameter is data, and third parameter is a position. First of all, we will check the position. If position less than or equals to 0, so means I need to call a function insert at beginning, and here I am calling a function insert at beginning with 2 parameters head comma data. Otherwise, if function I am not inserting at beginning, it will go to the else part. Here else part, a new node that is of type of struct node pointer will be equate with the create node bracket data. So, I am calling a function create node and passing the value of data, and whatever it will return will be pointed by new node. After this I am taking a variable temp variable, and this will be assigned value of pointer of head. Here I am taking one loop. The loop starts from I equals to 1, I less than position, and I plus plus. After this means the thing is that I am just comparing the temp. If temp equals to null, means if temp is null, then simply I am writing a message a position exceeds the length of the linked list, inserting at the end. And after this I am calling a function insert at end, and here this function takes 2 parameters head comma data, and simply it will return. Otherwise, the temp of next will be pointed by the temp. This is how we can the next of temp will be provided to the temp, and if condition is false, then the temp of next will be pointed by new node of next, and new node will be assigned to the temp of next. This is how we can write the code. Now, we will talk about delete a node at position in the linked list. Deleting a node at a given position in a linked list involves adjusting the pointers of the neighboring nodes to remove the nodes at the specified position. Here are the some steps that to delete a node at the given position in a single linked list. We have certain steps. The first step is start, beginning at the head of the linked list. Second step is initialize the current node, set a current node pointer to the head of the linked list. The third step is traverse the list until you reach the node just before the desired position. This means moving through the list position -1 times. The next step is update pointers, set the next pointer of the previous node, that is position -1, to point to the next node that comes after the node being deleted. Fifth step is free memory. If needed, free the memory occupied by the deleted node, depending upon the programming languages memory management. And the last step is end, that is deletion is complete. Here I am writing a method like delete node. In this delete node I am taking 2 parameters or arguments. The first argument is head and second argument is data. I am just comparing. If data head equals to null, I am simply writing a message linked list is empty and cannot be deleted. If head of data, the head of data equals to data, means I am simply comparing the data with the head of data. If this goes well, if this is condition is true, then the value of head will be assigned to the temp variable, and after this head of next will be assigned to the head, and we can now free the temporary variable and we can simply return. This is how we can delete the node at the given position of the linked list. Now we will talk about how to delete a node from a given data. So I am writing a function to delete a node from the I am writing a function to delete a node with the given data from the linked list. Here I am taking a method or function called as delete node. In this delete node, I am taking two parameters or arguments. The first argument is head. This is a type of struct node pointer, and second argument is data. And this function does not return any value because I am taking void type of this function. The first thing I am going to do is, if I am just comparing the head value with the null. If head equals to null, I am simply writing a message linked list is empty and cannot be deleted. After this, if condition is false, now I am checking the head of data with the data value. I am writing here the value of head arrow of data equals to data, means if condition is true, the value of head will be assigned to the temporary variable, and this temporary variable of type of struct node. After this, the struct node, I am simply head of next will be pointed by the head, and this and after I am just freeing the memory with writing free temp. Now the temp will be removed, and last I am returning. When after returning, I am simply writing another variable like temporary variable, the temporary variable of type of struct node pointer, and assigning the value to the head. I am writing here a while loop. In this while loop, I am simple putting a condition like temp of next does not equals to null. This is the condition. If condition is false, then while loop will not be executed. If condition is true, it will go inside this while loop. Inside while loop, I am writing a if statement, and this if statement says temp of next of data. This is this arrow operator assigning temp of next of data will equals to data, means data will be assigned to the temp of next of data. If this condition is true, then the next statement temp of next would be assigned to the structure node kind of to delete variable name, and after this temp of next will be assigned to the temp of next, and last I am just freeing the memory of to delete variable and I am returning. If condition is false, if this not goes well, it will go to the temp of next, and this will be assigned to the temp variable, and at the last I am writing data not found in the linked list and cannot be deleted. This is how data can be deleted. So there are certain operations as you have seen in this session. So the thing is that you should know how to use and when to use this linked list data structure, because there are certain things are involved with data structure like memory management and certain things. Certain operations are we can perform with the linked list. The thing is that there are certain complex algorithms also involved. Certain data structure like structure I am going to use. So you should know what is structure before learning this linked list. You should know how structure is working here. How can we define a structure? How many members we can use in this structure. So first of all, this complex programming, you should know the certain things before starting your linked list. Certain operation like insertion, deletion, updating, starting position and starting position, how the pointer works. So the certain things like structure, pointer, you should know before starting this linked list. Linked list nothing but it is a kind of data structure which takes one node, and node is can be segmented two parts, single linked list. The first part denotes the data and second part denotes the reference or pointers. One thing I want to add here, the data can be of any float value, double value, any character value, not necessary it can be only a decimal value or integer value. The thing is that when you start learning this linked list, you should know certain data structure, and means the complex programming will be easier if you know the certain things. So with this words I am just conclude my session. Thank you so much. Thank you.